Now, the basic reason or objective would be to protect the environment, and then number two, to comply with government standards. Otherwise, if you fail to comply with the government standards, when we discuss Clean Water Act, you would learn that each water quality parameter would entail you 5,000 pesos per non-conformance of water quality parameter. When we try to treat either water or wastewater, what are we trying to remove? We're trying to remove any of these pollutants or contaminants. So we have trash and grit, organic solids, nutrients, ammonia, disease-causing organisms, metals, and toxic compounds. These actually affect the different water quality parameters that we have discussed previously. However, you are not going to monitor as well as measure or analyze all water quality parameters because that would not be sustainable. So depending on the usage, for example, you want to analyze a particular quality of water, that would only mean monitoring certain number of parameters. Namely, for water quality, this is actually being monitored with the assumption that the water or the raw water being characterized will be utilized or will be treated for us to meet the Philippine National Standard for Drinking Water. So what would be the basic or the major water quality parameter to be monitored? You have the TDS, you have the pH, the temperature, turbidity, and fecal coliform. However, if you're just monitoring or just analyzing wastewater for the purpose of just discharging it to the body of water after treating from a wastewater treatment plant, the standard utilized would be the DNR Class C effluent standard. You can find this from RA 9275. And what do you normally monitor? You monitor TSS, BOD, COD, NNP, as well as the fecal coliform. Now, we mentioned a while ago that the different water quality parameters would at least give you an idea what kind of treatment to be utilized. So normally, if it is a physical water quality parameter affected, the type of treatment would be physical. That goes through with a chemical water quality parameter and also a biological water quality parameter being affected. One of the natural ways of treating water or wastewater would be the utilization of wetlands. So you're familiar with marshlands, swamps, and sometimes this is being done pre-treatment or post-treatment. So you have some industrial plants or wastewater treatment plants in industries with oxidation ponds prior to the treatment and after the treatment. The purpose of which is to naturally expose the wastewater or the water into the environment to naturally degrade remaining contaminants or pollutants. Well, now, with respect to wetlands, they also imply the principle of phytoremediation. So wetlands would normally involve shrubs and some small trees that would serve as a filter to some of the dissolved and suspended solids present in the water. Other than the natural processes, you utilize unit operations and unit processes that you have learned in chemical engineering in water and wastewater treatment. For example, for the physical methods, these would refer to processes where no gross chemical or biological changes are carried out. So strictly physical phenomenon, so therefore this would refer to your unit operations. So example would be pore screening to remove larger entering objects, sedimentation, normally utilized for water treatment, but for wastewater or sewerage treatment plant, we use clarifiers or clarification. Other examples of physical methods would be aeration, which can also be classified as a normal process. Then you have filtration, flotation and skimming, degasification, and then equalization. Now, for the physical processes, normally in any water or wastewater treatment, you have several basins that are in series. For example, you have here the flash mixer, which is otherwise known as coagulation tank. This is where you have the coagulation addition. Then, normally also this is where you add the equalization of pH or the control of pH. Now here, the flash mixers would have a turbulent mixing, rapid mixing. Why? So as to ensure that there is a uniform mixing of chemicals to that of the water or wastewater. Then this will be followed by flocculation basin. What's the purpose of flocculation? Flocculation is actually happening after coagulation. So the coagulant and colloids stick together to form flux. And since this is the function that you want to attain for your coagulant, what do you think would be the rate of the mixing? You still have the mixing to ensure that there is uniform spreading out of chemicals, but what do you think would be the flow rate? It should be now slower or relatively slower as compared to that of the coagulation tank, because your objective is to settle all the flux down at the bottom of the flocculation basin. And then finally, you have in the series the sedimentation tank or the clarifier if you're using a sewerage treatment plant. Now, if you would compare again the flow rate of this with this one, this would be the slowest. So most likely, you attain here or you maintain here the laminar flow. What's the purpose? So as to completely separate the flux, which would serve as your sludge, from your effluent or from the water being treated. This is an example of an STP or sewerage treatment plant clarifier. So you know this class that the clarifier would be somewhat in a conical shape. Why? So as not to use anymore any pump. You remember the funnel? So it is designed something like that so as to facilitate the separation of the flux to that of the effluent. After undergoing the sedimentation process, the next thing would be your filtrate or your effluent, or sometimes called as overflow, will now be further filtered. Now, filtration is a process of removing particle matter from water. Particulates would include the following. So you would know that these particles would have various sizes, and therefore that would tell you what kind of filtration is to be implemented. So there are many types of filter. You may have the granular bed filters. You have the granulated activated carbon, which is normally utilized if you have problems on odor and taste. Then you have the pre-coat filters. Then you have membrane filtration, reverse osmosis, electrodialysis. And here for the filtration, what matters is your design of the depth versus the cake filtration. Now, how would you know which is more appropriate? As mentioned, it depends upon the size of the particulate that you are separating. Based from this graph, this tells you what would be appropriate if the size would be from this point up to that point. So the normal process or the conventional filtration would be the rapid sand filtration. If you have very small particles, relatively smaller than that one, you have the microfiltration. And then, as it gets smaller, you have the ultrafiltration, and finally you have the reverse osmosis. Now, for the rapid sand filtration, this is the one that utilizes the anthracites, the sand, and so on as the normal filter. And normally this being utilized if you have good water quality with larger sizes of suspended solids and dissolved solids. This is an example. So after coming from the sedimentation tank, the effluent, or sometimes called overflow for water treatment, would just go directly to the filtration system. This is a typical filter bed or a wastewater with a wastewater backwash. Because you all know that your filters would need to be maintained. Therefore, one important design of your filtration bed would be the backwash, so that you can recycle the filter to the front of the plant or send to sewer. Now, this is an example of a backwashing facility being utilized in Putatan during the time of Ayala Land. Okay. This is actually made of coarse bubble diffusers so as to give some pressures to clean the filter. Now, the next type of filtration is microfiltration. As you can see, this is most effective with these sizes, very small sizes. And normally, what is being used here are plastic materials, very fine plastic materials, and this is actually a 510 type with an area of this one. So you imagine how small it is. And therefore, this would also give you an idea of its operational cost. Why? It would be there. It's a filtration setup, therefore it also needs backwashing. So this would entail higher cost, especially if you recycle the filter or you clean the filter. This is another example of this kind of filtration, microfiltration. Now, after microfiltration, your next option, depending on the size of your particulate, would be the ultrafiltration. You notice how varied the particles that could be filtered if you're using an ultrafiltration. You can have these bacteria around 8 to 17 micron, and even some colloids of this size. Okay. However, again, this would give you an idea how costly to maintain such an ultrafiltration setup. Because take note, based from this, the ultrafiltration involves the pressure-driven separation of materials. Take note of how high pressure you need to maintain. So you need to maintain 200 to 700 kPa, or about 30 to 100 psi. This is only to maintain the ultrafiltration process, but not includes yet the maintenance of the filter. This is how the filter looks like for an ultrafiltration. This would give you the mechanism on how to apply ultrafiltration. Okay. For the chemical treatment, this would involve chemical reaction or reactions to improve water quality. So just like the alu that we have discussed, just like the calcium oxide that we add to soften the water, these are examples of chemical treatment. Now, normally, physical and chemical processes are combined for a water or a wastewater treatment. So one of these combinations would be the use of activated carbon to absorb remove organics. We all know the reason why. Your carbon is known to have high porosity, so as to absorb some of the organics. Now, for the biological processes, this time, instead of using chemical as a way to improve the water quality, you use microorganisms to degrade organic waste. Now, it depends on what type of treatment or biological process would you like to do. That will be dependent on the type of microorganism you utilize. You can utilize aerobic biological process, that means involving bacteria with the involvement of oxygen. But if it's an anaerobic organism or microorganism, that means the microorganism doesn't need oxygen to proceed. with the biological process. But there's another type of bacteria being utilized in wastewater. We call it facultative. What's facultative? Facultative microorganisms are those which can exist with or without the presence of oxygen. Some of the biological treatments are shown in the figure. This is an example of an aeration process. So it's a biological treatment. It's aeration and it is exposed in the atmosphere. Therefore, what type of organism do we need here? Aerobic organisms. How about this one? This is what you call a trickling filter. It's actually a moving trickling filter. So you have here, this metal would have some strips of plastics, wherein each plastic would already contain strains of bacteria. So the strips would be passing through the water. That is with the assumption that the bacteria would be degrading the organics. So we call it trickling filter. This is an example of a trickling filter, but this time it's moving the other way around. This is another example of aeration. You notice this aeration is on top, but this one, it is being aerated through the bubble diffusers on the side and also an aerator submerged at the bottom of the aeration pond. Now, for drinking water, as I have mentioned, it would have the same concept. So, for drinking water, the task would be to remove the particle removal, or to remove the particles, to remove the organics, and then disinfect. We're talking about disinfection here. For disinfection, this normally is being done through the addition of chlorine. Now, chlorine may be in the form of solids or crystals. It may also be in the form of liquid. It may also be in the form of gas. Of course, the most effective means would be the gas. However, that would also pose some risk. For example, a certain chlorination tank of Maynilad somewhere in Noveleta exploded because of the usage of gas. So they shifted back to liquid chlorine. Now, since chlorine is a gas, therefore it easily dissipates. Therefore, you need a well. So this well would normally give a contact time longer for between the water and the chlorine. Now, this would show you the trend now in the waterworks operations. What are these? These are actually controls. Since the major parameters are easily fluctuating depending on the chemicals that you add, depending on some outside or external forces, therefore, and since you're delivering water, which is actually would affect the health of the users or the consumers, the industry is suggesting to monitor it through sensors. But of course, this would entail additional costs.